Hi, everyone. Hope everyone is staying warm and staying safe because, that's the most important thing. I'm just going to do kind of just a brief overview of what we're going to do in class. There was really going to be a lot of individual work as far as um, interpretation of ABGs. That's kind of what I want to work on. I want to make sure you understand how to interpret ABGs. So you can understand what that means and what your actions are, okay? But since class was canceled today, I kind of have to revamp things. I think I may do a little bit of a combination activity on Friday. I'm going to kind of think about how I'm going to work that out with the time constraints on Friday, but we will do our best. Okay, so we're going to talk about acid-base blood gas interpretation. And I know that the Sarah registered nurse RN, whatever, she has some videos up. And honestly, guys, they are great. There's no reason to reinvent the wheel. But I am going to go over a little bit of what she's talked about and kind of emphasize that. So just so you can hear it kind of from me. And we're going to do this in class. If you struggle with this, just make an appointment with me and I'm happy to sit with you, Zoom with you, work one-on-one at the college or whatever I need to do to try to help you out so you can hopefully understand this concept. Secondly, on the exam, there's like 10-ish questions. I have to double check the test again, but there's only a couple of these we're actually going to do interpretation. Well, I say that loosely. The important thing here is that I understand when you see somebody who is in respiratory acidosis, that you understand what your nursing actions are going to be. You kind of have to understand the concept of respiratory acidosis means that there's a ventilation problem or an oxygenation problem. And whatever that underlying issue is, you need to address it. For example, if it's someone with pneumonia, maybe you need to sit them up, turn, cough, deep breathe, give them the sensitive spirometer, give them a respiratory treatment. If it's somebody who is on opioid analgesics, and you know that can cause respiratory depression. And so if you have respiratory depression, they're not going to be breathing off that carbon dioxide. So they're going to be respiratory acidosis. So what are your actions? Well, if it's because of opioids, you're going to give a reversal agent. Or, help give that supportive care, oxygen, reversal agent, whatever it may be, depends on your choices. So a lot of your test questions are not specific to the blood gas itself, but you have to understand the blood gas. And yes, you will have to interpret a couple, but then you're going to have to know what your actions are going to be due to that blood gas. So just kind of keep that in mind. And I'm going to come up with a few practice questions for you guys before the exam. So that way you're hopefully really ready for this handful of questions that you'll see on the exam coming up here in a few weeks. All right, so let's jump into blood gas interpretation. All right, so I use the tic-tac-toe method. It's kind of how I was trained, and they do have the Rome method, and there's a couple other methods, but I kind of find that the tic-tac-toe method is the easiest. If you have already learned blood gases and have learned another avenue, well then, you know what? You don't have to listen to me. That's okay. If you have your own way of doing it and it works, knock yourself out. But if you are new to blood gas interpretation and would like to learn this method, and I think this is the easiest method, follow along and we'll do our best. I'm going to release, and I had them printed off to give to you in class, but we weren't in class. And I can still give you the printed handouts, but I'm going to release the actual handout and Blackboard. So if you want to work on it this week before Friday, which I think would be best, I'll give that to you to work on your own. And then we can kind of compare the answers after you've got your chance to work through some. All right, so 3 main questions. Is our patient acidotic or alkalotic? And that's all going to base on that pH. And then we need to figure out, is it a metabolic or a respiratory problem? And, well, that's all going to pertain to the PaCO2, which leans respiratory, or the HCO3, which is metabolic. So we'll figure that out. Once we figured out whether it's acidotic, alkalotic, and respiratory or metabolic, then we need to take it one step further to see if they've been compensating or if they're uncompensated. And hopefully you've already listened to my little videos. Basically, if you have a respiratory acid-base imbalance, the metabolic system is going to try to kick in and correct that. So the kidneys are either going to conserve or get rid of hydrogen ions. if you have a metabolic acid-base imbalance, the respiratory system's going to kick in by either breathing off carbon dioxide or retaining carbon dioxide. So it's either going to slow down the respirations or speed up the respirations. And that's going to make your carbon dioxide fluctuate within your body system. So that's how those systems help each other by trying to compensate. Keep in mind that the respiratory system, you can change your pattern of breathing almost instantaneously. It doesn't take it's not a long process. The body can make that happen pretty quickly. The metabolic system, on the other hand, it takes some time for that buffer system to really work in, for the hydrogen ions, for the kidneys to kick in to kind of either retain or get rid of those hydrogen ions. So the metabolic system, to try to compensate, it takes a little bit longer. Whereas the respiratory system, usually that can happen pretty quickly. So just kind of keep in mind. All right. All right. Again, the pH is the measure of the blood, whether it's acid or alkaline in the body. That CO2, again, is going to represent the respiratory system, and your HCO3 is going to be that metabolic system, and it's really controlled by the kidneys. So CO2, lungs, HCO3, kidneys. Okay. So when you look at your blood gas levels, if the primary problem is the CO2, it's usually a respiratory problem. If the primary problem is the HCO3, it's going to be a metabolic problem. All right, so you have to memorize your normal values. For the exam, what I would do, first step on your exam, because you have to have a blank piece of paper. And even I get confused looking at like 10 questions. The numbers start getting all jumbled and I'm like, oh my gosh, and I've been doing this for a long time, right? So what I would do, my hint to you, is on the exam, when you hit start, write down your normal values. Please write down your normal values. You can't write them down before the exam, but once you start the exam, then you can write them down. So write down your normal values, your pH, your PaCO2, and your HCO3. Write them up in the corner of your paper so you're going to have them to refer to, because we're going to try and probably confuse you, and you're going to need, I'm not going to try to, but it gets pretty confusing. So write those normal values down before you even start question number 1, so you'll have that to refer to so you don't get lost. That's my number 1 tip, okay, for acid base anyway. All right. How I like to do the interpretation, I like to line up my values. I always kind of like put them in the corner up there. Remember, our pH 7.35 to 7.45. Anything less than 7.35 is going to be acidotic. Anything greater than 7.45 is going to be alkalotic. Now your CO2, the range is 35 to 45, but you got to flip it because it's kind of backwards. Anything greater than 45 is going to be acidotic, so that's why the 45 is on the left side. And anything less than 35 is going to be alkalotic. So I flip it because I like everything to line up nice and pretty. And then your HCO3, which is your bicarb, anything less than 22 is going to be acidotic. Anything greater than 26 will be alkalotic. So that way, line up your normals, and so you know if your numbers or what your values are, wherever they're going to be, you can see whether it lines up on the acidotic side or the alkalotic side, or if it's normal. So that's my suggestion to you. You're going to create a little tic-tac-toe method, and I did one with a graph on here, but you can do it just on a piece of paper, just like a tic-tac-toe. And you want your acid on the left, the normal, and then your base. And I do mine a little bit different than old Sarah RN, registered nurse person, but it's very similar, very, very similar. So we want to kind of create a tic-tac-toe pattern to see which values will line up, okay? So problem number 1 I have here. I have a pH, and I've already filled them in. We have a pH of 7.30 and a CO2 of 50 and a bicarb of 23. So we know the pH is 7.30, and that is leaning on the acidotic side. So I put that in the acid column. The CO2, it is 50, so it's greater than 45. And remember, we flipped that CO2 because the greater number is acidotic. So I put that on the acidotic side. Now the bicarb is 23. And remember, your normal range for bicarb is 22 to 26. So I put the bicarb in the normal column. And if you look at that, you've got your pH and your CO2 line up in the same column. So this is a respiratory acidosis. It's in the acid column. The pH is acidic, and it's CO2, so it's respiratory. Remember, CO2 is the lungs, so it's a respiratory acidosis. And if you look here, the bicarb is normal, so nothing's going on with the bicarb. There's nothing going on with the metabolic system. It's just hanging out like it normally does. So this is uncompensated. There's been no compensation. It's uncompensated respiratory acidosis. Okay. All right, problem 2. And I'm going to try and fill this in best I can. Our pH is 7.49. So 7, let me pause this for 1 second. Okay, so we have our pH, which is, okay, I'm going to try and do this here while I'm recording. So our pH is 7 point, when it went too far. All right, so our pH, and I'm on problem 2. Our pH is 7.49. So if you look at that, if you remember your normal values, 7.49 is alkalotic. So I'm going to put my pH over here. Mind you, I'm marking on my computer on a trackpad. I'm not that good at this, but I'm going to do my best. So if we have 7.49, our CO2, on the other hand, is 40. Now remember, our normal values for carbon dioxide are between 35 and 45. So that is smack in the middle normal. So I'm going to put our CO2, if I can find my mouse. There it is. We're going to put it right here. 40. So that is normal. All right. Our HCO3 now is 28. Remember our values, our normal values are 22 to 26. So I'm going to put that in over here. 28. So if you look at what lines up here, you have a base of 7.49, so it's alkalotic. You have a bicarb of 28, which is also alkalotic, and our acid or our CO2 is normal. So we have a metabolic, because it's the HCO3, metabolic alkalosis, and the lungs have done nothing to try to help. They're still normal, so it's uncompensated metabolic alkalosis. Okay. All right. So let's try and go to the next slide. Okay. Here is problem 3. All right. So we have a pH of 7.29. Remember that pH, 7.29, our normal is 7.35 to 7.45. So that's on the acid side. I like to put my pH here, 7.2. Don't laugh at my writing. 9. And then our CO2 now is 37. Remember, our normal range is 35 to 45. So that is a normal CO2. So I'm going to put my CO2 in here, 37. And now our HCO3 is 18. Remember, our normal for bicarb is 22 to 26. So let's put our bicarb, and of course my mouse disappeared again. There it is. We're going to put it over here. We have 18. So what lines up? We have an acidotic, and it's metabolic because it's the HCO3. They're lining up in this acidic column. So we have metabolic acidosis. The lungs are still normal, so they've done nothing to try to compensate or to try to help anything. So this is uncompensated metabolic acidosis. Okay? All right. Let's move on. Now, remember I talked about compensation again. It's find the primary system causing the acid-base disturbance, which is what we just did. We kind of looked at the columns and said, what's in this column? Where is it leaning? And that's where we kind of find that disturbance. Has the other system try to kick in to compensate? And what does that mean? Is the other system, is it still normal? If it's still normal, then it's done nothing to try to help with this acid-base balance. If it's not normal, that means that it is working or it's trying to adjust or take care of the imbalance. For instance, if the respiratory system is making it too acidotic, the kidneys are going to try to kick in and make it more alkalotic to give it balance, to get that pH back between 7.35 and 7.45. And vice versa. If the kidneys are for some reason making it too acidotic, the lungs will kick in and try to make it more alkalotic by breathing off all that carbon dioxide. So again, trying to bring the pH back into normal. They're going to try to balance each other out. So, again, if the primary disorder is respiratory, we have to look and see if the bicarb has moved in the opposite direction to try to compensate. If the primary disorder is metabolic, we have to look at the CO2 to see if it's tried to compensate. That's kind of what we're looking at. Has the opposite system done anything to try to help correct this? And that's what we're going to do with this next set of 3 problems. All right, the compensatory system has tried to alter the correct the pH, but it has not done enough to fully correct the pH. So at this time, when it's partially compensated, the pH is still abnormal. Both systems are trying to kick in, but the pH still remains out of the normal range, okay? The pH is still out of the normal range, but both systems are trying to work to get it back into balance. It just hasn't worked yet, okay? All right, so let's look at these. All right, so we have, let me get my little inker up here. We have a pH of 7.47, and I've already filled that in. And remember, 7.47 is alkalotic, so I put it on the base side. We have a CO2 of 31, and remember, 35 to 45, you got to flip it. Anything less than 35 is going to be alkalotic, so I put it on the base side. But our bicarb here, it's not normal. It is 20, which makes it low. So it's doing something. So if you look here, we have a pH of 7.47, a CO2 of 31. So we know that's a alkalosis, and it's a respiratory alkalosis. But it does show that the kidneys are trying to do something to bring balance back into the system. They are doing something. So we have a bicarb of 20. So they're trying to make the body a little bit more acidic to offset the alkaline conditions that has been caused by this respiratory alkalosis. So that's what's going on there. And I know it's hard to understand with a video. I'm hoping we'll have a few minutes to work through a few of these on Friday, but that's kind of how that works. Now, let's move on to the next slide, and we'll do some ourselves. All right, so we have a pH of 7.31, normal, 7.35, 7.45. So that is lower on the acid side, so 7.31. So that's acidotic. We have a CO2 of 31, and so that's alkalotic. Remember, our low of our CO2 is 35. Anything less than 35 is going to be considered alkalosis. So I am going to move that over here. Okay, now our HCO3 is 20, so that is on the low side. So again, I'm going to go down here on the low end and kind of see what the put this over here with the acid side, because that's where it's on. It's on the acidic side of the column. So we have a metabolic acidosis, because you've got metabolic and the pH is acidic, so metabolic acidosis. And yes, the respiratory system is trying to do something to correct it. That's why it's abnormal. So you have this is trying to make it a little bit more alkaline to normalize that acid-base imbalance. Okay. All right. So let's go to the next one. Okay. Okay. Problem number 6. We have a pH of 7.19. And remember that pH, less than 7.35, it's on the acidic side. So we're going to put that in here, 7.19. Okay, and then we have a CO2 of 62, and that's really acidotic. So remember, it's way higher than 645. So again, that's leans on the acidotic side. So I'm going to put it in my acid column. So we have acidosis. CO2 means it's respiratory. The bicarb is 30. And remember, that's going to lean over here on the alkalotic side. So we have a respiratory acidosis because they're both lining up on the acid side. And the bicarb is abnormal. So the kidneys are trying to correct it, but they just haven't done enough to get this into the normal range. So we have a partially compensated respiratory acidosis. That's what we have here. Okay. Partially compensated respiratory acidosis. So now we're going to move on to full compensation. So when the compensatory system, so whatever's trying to do the compensation, has altered itself enough to fully correct the pH, so the pH is back into the normal limits, that's what we call full compensation. And so if we have a respiratory acidosis problem, the kidneys have kicked in, but they've done such a great job that it's pushed that pH back into that normal range. That's what we call full compensation. And we're going to figure out a few of these. Okay. All right. So, and I've kind of started with these. So we have a pH of 7.39. So I'm going to put that over here in the normal column because it's almost right smack in the middle. Almost. 7.39. This is our pH. So it is in the normal range. But if you look at it, you notice that it is leaning a little bit to the acid side. Even though it's normal, it is leaning acidic because 7.40 is dead middle normal. All right, so our CO2 is 49. Our CO2 is 49. So is that high or low, or acidic or alkalotic? Well, it's high, which makes it acidic. Remember, our values are 45 to 35. So CO2 is 49. Okay. Now our bicarb, our HCO3, is 29. And remember, that is a little on the alkaline side, or the base side. So we've got, this is a little on the alkalotic side. I'm going to put it over here with my base. Okay, so right now we have something that has been fully compensated, but how do we know what the actual underlying disorder is? Well, there's a couple of ways to kind of look at this. So we have 7.39. This is leaning acidotic, so I'm most likely inclined to think that this is going to be our acidotic value is our CO2. So I'm leaning to say this is going to be a respiratory acidosis that's been fully compensated by the bicarb. But to fully check, we need to kind of measure things. So remember, we have, this is 4 points out, or 4 measurements out of the normal range. So we got 45, we got 46, 47, 48, 49. So we've got like a disturbance or a excess of 4 here. Okay. We're over here on the base side. Remember, our high normal is 26. So we've got an excess of 2. So, again, it looks like we were right. We've got more of the deficit here. So this is probably our underlying disorder. Of course, you're always going to evaluate your patient, but this looks like a respiratory acidosis that's been fully compensated. And all I did is to see which of these were the most out of range, which is usually going to be your underlying problematic system. Okay. All right. Moving on to the next one. Here is problem 8. All right, so we have a pH of 7.43. Again, smack in the middle. Well, not dead smack in the middle, but in the middle. And if you notice, this, even though it's normal, it is leaning basic. It is kind of leaning that side, but it is normal. So it has been fully compensated. Oh, it looks like I left the CO2 off of there. I will just fill one in. So we have an HCO3 of 31. So an HCO3 of 31, remember our normal range between on our bicarb is 22 to 26. So this is going to be a deficit or an excess of 5. So I'm going to put plus 5 here. And I'm just going to make up a value because we want this to be acidotic. So I'm just going to call this, oh gosh, I don't know. Let's just call it 47. Okay, we'll just fill that in there. We're going to call this 47. I'm going to fill that in right there. 47. Our CO2 is 47. All right, so if our CO2 is 47, that is acidotic, but it's only out of range by 2. And I don't know why I put 50 over there. That should not have been there, so ignore that right there. That should have just been 5. So this is just 2. I'm getting all excited with my trackpad here. All right, so we have a change of 2 on here. We have a change of 5. This is the one that's most out of range, and our pH is leaning alkalotic. So I'm going to call this HCO3. That's metabolic. We've got metabolic because we're metabolic alkalosis, and it's fully compensated because the CO2 has pushed it into the normal range. It has compensated enough that it's put it into the normal range. Okay, hopefully you can kind of understand that. Let's do one more, and this one is going to be kind of the confusing one, sort of. So again, we have a pH of 7.40, and this is that absolute normal. It doesn't get any more normal than this. 7.40. Our CO2 is 33, and if you think about that, that's going to be on the alkalotic side. Oops, shoot. Let me erase that or undo that. Okay, let's try again. Okay, here we go again. Sorry, I screwed that all up. 7.40. As you can see, I struggle with my trackpad. Our CO2 is 33. That's on the base side. Remember, 45 to 35. So let's measure 33, 34, 35. We've got a deficit of 2. I'm just going to put 2 on here. We've got 2. And then on our bicarb, it's 18. So we know that that's acidotic. 18. And remember, our normal range for bicarb is 22 to 26. We've got 18, 19, 20, 21, 22. So that is an excess of 4. Okay, so this is the most out of range. Even though this is absolutely normal, it's not leaning one way or another. We can tell that this is most likely our problem system because it is the one that is the most out of range. So we're going to call this HCO3. That's metabolic, and it's in the acid column. So metabolic acidosis, fully compensated because our pH has been moved back to normal. Okay. All right, so I have, all right, oh, I'm just having trouble with all my little pens here. Too many options. Anyway, so that is basically the end of the slideshow. Now, I'm going to release a handful of problems. Again, I had them all printed up for you, and I was planning on giving them to you today. And we were going to work through them in class, but we unfortunately couldn't do that because of the weather. So what I would like for you guys to do is to work on these this week. I think I have like 30 problems. And I just want you to work through them on your own. If you get stuck on something, let me know. I'm going to release the answers probably on Wednesday or Thursday. I'll release the answers. And I want you guys just to grade them yourselves. Just check yourself and see if you got most of them or if you didn't. If you got one, if you didn't miss one or you got stuck on one or you're having some issues with one, let me know and we'll talk it out. I use a program that automatically generates these blood gas values, and occasionally there's a little one that gets a little weird on there, like if it's a combination metabolic and respiratory blood gas disorder, which I don't want to give. I'm probably not going to give you a lot of combination. In fact, you're not going to have any main combination disorders on your exam. We're really just trying to get the basic gist of this. That's really kind of what our focus is. So I want you to work through these problems on your own before Friday. And then when you come in Friday, we're going to do a little activity on how to, now that we understand how to figure out which acid-base disorder it is, what are we going to do about it? And I want you to really focus on that part in your book. We're going to kind of like focus on that and have an activity that will relate to that. So if you have any questions for me between now and Friday, just holler at me. Sorry I look so bad. I'm freezing, and I'm just cold, and it's just kind of miserable outside. Anyhow, email me if you have any questions. I'm sorry I missed you guys today at school, but things happen. So, good luck with your studies and with these acid-base problems. If you haven't watched my little YouTube videos, please do. I do go over some examples of what can cause certain underlying acid-base disorders and what have you. So make sure you kind of review those at least before Friday. They're not long. I do and almost all my lectures. I have a few long ones, but almost all my lectures are like, 20 minutes or less. They really aren't very long at all. So make sure you look at those. Again, email me with any questions, and I hope you guys stay warm and stay safe. Bye.